Hi, welcome to the channel. So today I'm going to continue working with Pandas, Seaborn, Plotly, and I'll be doing a cohort analysis. So this is a very typical type of analysis that's done with retail data. So I'll continue working with the online retail dataset, and these are some of the topics I'll be working on. So it's mainly doing some data wrangling with Pandas, and we'll be using groupby, pivot table, merge, transform. And at the end of the video, I have a bonus where I do a code refactoring. And I think this is a really important step where you grab all the code that you worked on the notebook, and at the end of it, you convert it to something that you can reuse in other projects. So what I'll be doing, let me show you at the end, basically create a few functions that make everything I did in the notebooks that might be a little bit messy at some point. It's a lot more human comprehensible for other people that might read your code. And okay, but you'll have to stick until the end to get to that part. So the first step is reading the data. So here I have some libraries that I'm importing, and this is the code that I developed in the previous video of this series. So here I'm just passing the input file, reading it from Excel, and just changing the column names to something more descriptive. And that's all lowercase and has this underscore instead of spaces. So I also create this column called sales, that is the quantity times the price. So I'm just going to run this, and now I'm reading the data. Okay, so there it finished reading it. And okay, this is more or less how the data looks like. We have an invoice ID, the item ID, a description of the item, the number of times it's sold, the date, price, customer ID, country, and sales, that is quantity times price. So this is mainly the data that we worked in the previous video. We did some exploratory analysis. The first question that we have is, how many NA values do we have in terms of the customer? So here we create a Boolean vector that has trues for nulls, null values, and false for non-null values. So if we sum it, we're summing all the null values. So how much is this? 107,000. So the data has 525,000. So okay, we have like 1/5 of data doesn't have any customer ID. So as this analysis requires the customer ID, I'm just going to remove this data, but we just need to know what we're doing, right? So here I'm filtering the rows that have a null customer ID. So basically the way it works is we have this Boolean condition, df.customer ID is null. So, and we kind of inverse it by using the tilde. So we just filter the ones that are not NA. Okay, so the next step is to get an idea of the start date and the end date of the data. So we have more or less 1 year of data. And then what I'm going to do is create a column that has the year and the month. So let me show you how this looks like. So basically I grab the date column, I use .dt, and then I call toPeriod with the monthly frequency. And that generates this column here that has the year and the month. The analysis I'll be doing is at the year month level. So that's why we want to do this. So we just added a column to the data. It's just taking this field here and collapsing it, cutting it there. So we have the first values. So the next step would be to create an index for each month. I want to have a number that represents each month. So this is how this data frame looks like. So it's kind of like a lookup table. So for each year month, I define this index that goes from 0 to whatever number of months we have, 12. So basically here I define the unique year month values. I pass them in this data frame, and so I create the data frame with these values. And this is just counting from 0 to the number of months. So MP range does that. So if you take a look at what MP range does, so if you pass 5, it counts from the index 0 to the 5th index. So here we have this value. So if we do shape 0 that has 13, we can do a range, and that's what the index column is, how the index column is created. Okay, so we have this lookup table, right? And now we can add this index value, we can merge it back to the original data frame. So what I want to do now is to add it as a column here. And the way to do this is with PD merge. There are multiple ways to join columns in Pandas, but PD merge is the most flexible one. So I just learned PD merge well, and that's all I needed for working. So here we pass in the df as the first object, the unique month on the right, and we do an inner join. So it's really the same to do a left join or inner join in this case, because we'll have a match for all the ym values, and then we join by year month. So let's take a look. And okay, and this is what we get. We just added this column by joining it by year month. So this is a really important function to know how it works in Pandas. Very common operation to join multiple data frames. Okay, so let's continue. So the first start of the cohort analysis is here, and this is probably the most important part. So here df dot group by, so I'm grouping by customer ID, that is, well, the customer ID, and then I'm keeping this index column, right? It's the number I gave to the month, and I'm computing the minimum value. So basically I'm grouping by customer, selecting the index column, and I'm keeping the minimum value for each customer. So what that will tell me is the first month, more or less, the index that the customer made a purchase. Okay, so let's do head here, so you can see what happens, and that's how it looks. So depending on when the customer made the first purchase, they will have a value there. So perhaps if I do a sample, we can see some different values. So it won't always be 0 here. Okay, so this is the, so for example, this row is interesting. So here, this is the 10th month, but the minimum value is 3 for this customer. So so that's basically what we're computing here. The first month they made a purchase. And the transform function, what it does is, instead of grouping by and aggregating the data, we just create a column on the original data frame. So it returns the same amount of rows as the data frame. Okay, so if, for example, I would do this, and I would do sum, for example, the shape of this would be the number of customers, right? But if I do transform, it will be of the same size of the data frame. So it basically repeats the information. But it is a very important thing to understand how this what is the difference between when you aggregate and when you transform the data frame. Okay, so one more step we need to do is we'll create some sort of inverse mapping with the months, the year month, and an index. So this is how this looks. So basically here I'm looping through these unique months. It's a really small data frame, so I can just loop through it. and I'm using a dict comprehension here. So the output of this, it's kind of like a list comprehension, but for it returns a dict. So if I filter 0, it will give me this value. If I filter 1, it will get this value. So for example, say if I pass in the first month, okay, integer, so I get this value. Okay, so that's how this mapping is created. And now I can just go back to my data frame. So let me show you the data frame here. So we have this cohort ID we just created, right? So we created it here by keeping the minimum index. The customer joined, the customer made a purchase. And so what I'm doing here is just, instead of having a number here, I just want to have the month that they joined. So let me show you what we get here. So we get a year month that is associated to this value. So what map does is you pass in a dict, and it creates the column based on the dict keys. So it's kind of like a join. So we could have done a merge, but it's a more compact way of doing it. It makes sense when you have few values. Okay, so we got to this point now, and the final step is computing the difference between this index and the cohort ID. So, and this is the hardest part of all the pre-processing. It'll make sense in a second, so bear with me. So let's review what we have here. So this is the year month that a sale took place. So same of this, it comes from here, from the date column, right? So this is the when the sale took place. So the index, what is the index? So it's just a number that we have associated to this month. Okay, so well, this is May, so it's the 5th indexed. And cohort ID, so that's the index when the customer made the first purchase. Okay, so it's the minimum value of the index for each customer. So we can go back here and see how the cohort ID got created. So we're grouping by customers, selecting index, and keeping the minimum value. Okay, so now we know how the cohort ID got created. And then we have the cohort year month, that it's basically just putting a date that's associated to this value. So the 0 is the first month. And yeah, and the cohort index, so that's the last calculation. Here, what we're doing is just computing the difference between the current month of the transaction and the first month of the transaction. So it just gives us an idea at each observation what is the difference in terms of months between the first purchase and the current purchase. So, okay, so now that we have these calculations, that I think it's important that you take some time to go through them little by little until you understand them or they make sense to you. So it's not that easy, but I think if you go through the code yourself, you can understand it. So once we have this, okay, what can we do in terms of analysis, right? So here we have this cohort ID, that's the index of the month when the user made the first purchase, and the cohort index. So that's the difference between the current month, let's say the current index, and the first month the customer made a purchase. So if I group by these two columns and select the customer ID, I can compute the number of unique observations. So that will tell me for each cohort ID what is the number, the unique value, the number of customers that are present at this combination of variables. And the rest of the pre-processing here is just resetting the index and changing the column name. So let's see what we get here. Okay, so this is the cohort ID, this is the cohort index, and for each value of these two variables, we compute the number of total customers. So then what I can do is I can pivot this table and so basically convert it to a matrix. And I'll keep the cohort ID as the index, the cohort index as the columns, and then the values will be the number of customers. So let me show you. Okay, there it goes. So basically what we have here is for each cohort ID, and we have the cohort index in the columns, and we have the as values we have the number of customers that are present at each step. So then what we can do is just assign this index mapping to the rows, and I think now it starts to be easier to interpret. So you have the month of the cohort, and these are the number of months that the customer remained. So basically, for the customers that made a purchase this month, so we had 1,044 customers, but in the second month, only 392 made the purchase, and then that got reduced. And I mean, it changes a little bit, but basically, this is the progression, right? So, and then for the other cohort, so we had 394 customers, and then the next month we only had 86. So we dropped quite a bit here. And that's kind of this cohort analysis, the logic, right? So the final step is to scale it so it's a percentage. So we'll take this column here, the first one, and we'll divide the rest of the columns by this column. So we start at 100% at each cohort. And so this is what I'm doing here. I'm selecting the first column, and then I'm dividing the data frame by the cohort size column. And this is what we get, right? And it's starting to be a little bit more interesting now. So we have a percent value, and we can understand what the evolution of the business for each cohort. So think of cohorts as a group of customers that made a purchase at a given month. So then finally we can plot this as a heat map, and here is the code to do that. Basically just define a figure, find a title, call Seaborn Heatmap, just pass in the data frame and a few other options. So I think this one is the most important one. This defines the color scheme, and basically this is the most important plot for the analysis. So it shows that at the start of each cohort, we start with 100% of the customers, and then the rest of the months we get a lot lower sales first, and then some come back here. So this increased, but it kind of stabilizes around 35 and 40%. I think the first one is the most interesting one. We have a lot more information. And then for the next one, we see a larger drop here. So it goes from 100 to 22, then it goes up a little bit, but it's even worse than the first one. And the third one, yeah, around the same. This is the main result of this analysis. So I have a few more things I wanted to show. I'm going to plot the retention rate as line charts. So basically, this DF result is the matrix that we have here. So let me show you here. So it's this matrix. And if I do this, I convert it to a long format again. So here I'm just changing the name. I need to change the cohort ID to be a timestamp. Just run this line. I mean, this still looks relatively similar to what we had before. But if you check the data types, so this is a datetime object. And this is a requirement of the library. So here I'm using Plotly Express, so you can look at the help here, and let's take a look quickly. And basically, we have to pass in the data frame, the X variable, the Y variable, and some other arguments such as color. So what I'm doing in this situation is passing the data frame, then define the x-axis, the y-axis, and the color. So the color defines the number of lines that you want to be plotting. And this is another way of looking at the same data. So it starts in 100 and it drops. This is kind of what we were looking in this heat map, right? How it drops initially, and you can here you can remove a few of the cohorts, so it's maybe easier to look at the plot. But we see this big drop in the start. So finally, here comes the bonus, and this is how you can do the refactoring of the code. So what I did here, I just copy pasted the code that I used above, and I created these functions and ran the analysis. So here I have the libraries, the function to read the data. This is the pre-processing function, so where I do all the data wrangling in order to create the matrix that we do the analysis. So actually, this is just pre-processing on the original data frame. This is where the matrix gets computed, the F result. So I'm doing the group by, then pivoting it and doing the other calculations. So it gets to be a percentage. And then I have another function for the heatmap plot. So here you can do this, and basically the preprocess function, if you read the code, it reads the data, keeps the complete observations, creates the year, month, column, etc., etc. And so it starts from 0. I mean, you could copy all this code and put it in a different notebook and try to apply it to other data sets, or just understand how a cleaner version of this analysis would look like. I think if I see some code of a data scientist and it looks like this, I get a lot more positive reaction. It shows that you have experience, you know how to write good code, and this code makes things easier for everyone. So there it finished the pre-processing, so it creates all the columns. So here we create the matrix, compute the retention rate, and this is the code for the plot. So you can just create a function and pass it to the data frame. So basically, I think the takeaway here, besides the analysis, is that you can summarize an analysis with a few functions, and that helps other people to use your code, read it, understand it, and it helps you when you need to review this analysis. Okay, so that's it for today. I hope you enjoyed it. Let me know in the comments what do you think, and please subscribe and like the video.